Hey guys, so it's been a nice long weekend. Hope you guys had a great Memorial Day. What I wanted to do today is go through and look at some stuff about the quadratic formula. Kind of dissect the video that you watched on Friday. So that's what we're gonna do. All right, so memorize the formula. Well, okay, so, I'm not a big fan of memorizing things, but this is one of those ones that's going to come up a lot. So it's like top 5 formula in math. It's pretty useful, so you're going to want to memorize it. I'm not saying memorize it, like, for me, considering we're, like, towards the end of everything, given our circumstances of being at home and whatever, but it's going to come up again, so you're going to want to memorize it. So we're going to go through it. Keep the slide deck for reference for the future. You'll see this again next year. Algebra 2, geometry, all of your future math classes, calculus, it keeps coming up, so you're going to want to memorize it. Alright, so thing is here, you got to start with general form. So remember when we were doing factoring, and in factoring we had to make the equation equal 0. It's the same thing here. So this one side here has to equal 0. So if it doesn't equal 0, make it equal 0. So go through and you're going to want to, if it equals 10, subtract 10 from both sides. If it equals 5x, subtract 5x from both sides. But you got to make one side equal 0. Alright, so let's take a look at it. I look at this sometimes and I'm like, it's pretty scary, but don't worry, you're going to get used to it. We'll go through a couple of slides here to go over it, make sure you understand it. In the slideshow, I'll share it with you. There's this link here, so you can always go ahead and click on that link if you want to have some more practice with the quadratic formula. It will just take you to Khan Academy. Alright, so let's take a look at the example here. So in this example, we have to identify the coefficients for A, B, and C. First, make sure it's in the right form. So I look at this, we got to make sure it equals 0. So it definitely does. So we're okay there. Next thing we need to do is identify what A is. So A is going to be the coefficient of x squared. So when I look at that, there's nothing there. So when we think about what the coefficient of x squared is, that's that invisible coefficient of 1. It's not 0x squared, that's 1x squared. Then we have B, so we're going to look for B. B is going to be the number in front of x. Here it's 4. Last one, C, is going to be the number hanging out by itself, but it's not just 21. Don't forget the sign. C is negative 21. That's the first step. Next we're going to go ahead and substitute these in. So they are here substituting this in negative b, so we've got negative 4 plus or minus the square root of b squared. That's 4 squared, which is 16, minus 4 times 1, that's a, times c, which is negative 21. All over 2a, which is 2 times 1, so 2 times 1 is just 2, so they didn't write that there. They didn't write out the multiplication. So it looks pretty complicated. It is not. Take it piece by piece. Use your order of operations. So we're going to go with grouping symbols first, because grouping symbols are first in GEMS. So we'll do everything underneath this square root symbol first. 16 minus 4 times 1 times negative 21 is 100. That is way easier to work with than the big old expression that was there. Square root of 100, easy peasy. So negative 4 plus or minus 10 is what you have next. And then what they do in the last step is they do negative 4 divide by 2, and then 5 divided by 2, and they get negative 2 plus or minus 5. So don't forget that plus or minus means we're going to do Negative 2 plus 5, that gives us 3. Negative 2 minus 5, that gives us negative 7. So what does the solution tell you? Well, these two solutions are the x-intercepts. These are going to show you where y equals 0. So if I take the equation y equals x squared plus 4x minus 21 and graph it on Desmos, here's what I get. So take a look at it. There's negative 7. There's 3. So it's, a nice, easy equation to find the solutions on a graph. It's also easy to factor it because, if we take a look at this and we factor it, the factor form for this equation is going to be x plus 7, x minus 3. So, that's easy to factor as well. That 0 looks weird. Let's do it again. So why would we even want to use the quadratic formula if we could find the solutions easily on a graph, or find the solutions easily with factoring, which is something we practiced last week? That's because life is never that easy. So in the real world, your numbers aren't friendly. I mean, when we think about the applications that we have with physics, quadratics in physics and quadratics with other things, you're going to have numbers that are not so friendly. A lot of the projectile motion graphs that you'll deal with in physics involve gravity. So you're going to have the number 9.8 in there, or something similar. So it gets kind of messy. So let's take a look at an equation that's difficult to factor. Here we go. Now, notice on this equation, it equals negative 10, so we have to add 10 to both sides. And that's going to get that one side equal to 0. So you can see there then A now is 3, B is 6, and C is 10. So when we substitute all these numbers in, we find out that we'll do underneath the radical symbol here. Just let me get a pen. You have 6 squared minus 4 times 3 times 10, so that's your b squared minus 4ac. When I evaluate that, what I end up getting is 36 minus 20, or the square root of negative 84. So right there, when I try to take the square root of negative 84, we know that the square root of negative numbers don't exist. There's no number that I can multiply by itself to get a negative 84. So in that case, we would say there's no solution. And what that means then, and I was hoping that I could click on this Desmos link and take you to the graph, but I can't. But you can certainly do that. But what ends up happening, oops, I don't want that. Let's get a pen. What ends up happening on the graph, though, if I graph this equation, y equals 3x squared plus 6x plus 10, I get an equation that sort of hovers above the x-axis here, and it's never going to cross the x-axis, so there's no x value that I could put in the equation to make it equal to 0, so we would say there are no real solutions. So if you ever get the square root of a negative number, there is no solution to that, no real solution. Yeah, there's imaginary numbers, and yeah, we'll talk about those in Algebra 2, but we're not going to do that today. So we would just say no solution, and even if it were a positive 84, we know that that is an irrational number, so it's not going to come out to have a really nice decimal answer, because the square root of 84 has decimal places that go on forever. It's like 9 point something with infinite decimal places. So it's not going to be friendly like that first example that we did. All right, so some tips. Make sure that it's in the right form. Make sure it equals 0. If it does not equal 0, then you can't identify A, B, and C correctly, and the formula won't work. Just like when we did factoring, we had to make it equal to 0. Second tip, make sure that when you look at the part underneath the radical symbol, make sure the whole thing's under there. You want to have b squared minus 4ac all under the square root symbol. Make sure 2a is on the bottom and everything else is above it. So that fraction bar, that vinculum, is going to be really long. Watch your negatives. It's helpful to use the parenthetical promise because when you're substituting a negative b in there and you square it, we know that if we do a negative times a negative or any number times itself, it's always going to come out to be positive. So make sure that you keep track of those signs. Make sure that you keep track of the plus minus because you got to be on the lookout for two solutions. Your graph could cross the x-axis 2 times, so you need both solutions to have a correct answer. Last tip, just be aware that, if you type in an irrational number into your calculator is going to round it to a certain number of decimal places, and that's fine. But if a question asks for the exact answer, and that does happen a lot, certain square roots, any square root that's not a perfect square, can't be simplified. So you want to just keep the square root symbols in there. This right here is the exact answer. If I went and typed that into my calculator and got the decimal, that would be the approximate answer. So it's equivalent to using the symbol pi versus 3.14, just like we discussed back with rational and irrational. Well, that's about it. So we'll do some practice tomorrow. Go over that, but we're heading towards the end, guys. We're almost there, okay? Hang in there. We'll see you on tomorrow's post. Bye.